accepted, challenge accepted. The attitude is always challenge accepted. Challenge accepted, challenge accepted. The attitude is always challenge accepted.
Welcome back after the lunch break. We're about to start our next talk, so please come in.
Може да вземете и сандвичите с вас, евентуално, probably.
Sandwich accepted. All right, you filled your stomachs with sandwiches, but what about filling your brains with mind sandwiches?
Prepare for some magical wisdom from the CSS wizard Harry, who is becoming a fixture at Dev Challenge Accepted.
Think of Harry Roberts as the favorite godparent of big companies, from the United Nations to the BBC, making their websites load faster. Google and Cloudinary Media are basically his fan club, calling him a tech genius.
Whatever we say about Harry will be an understatement and at the same time redundant, because everyone who knows who he is. Harry is like a rock star in the field of CSS optimization.
We're certain you're all eager to hear his talk about optimizing the largest contentful paint, but you will not hear it, because just a week ago he came up with brand new and even more exciting topic. What it is? What is it? You'll hear it straight from the CSS wizard himself, Harry Roberts!
Cheers, guys. Thank you so much. Those guys are great. This whole event is great. I said to Peter, I spoke here last year, and I said to Peter, if you ever invite me to speak at this event again, I will say yes immediately. This is a huge talk. I don't have a lot of time for a big intro. If I could just get my slides up on the screen. But yes, there has been a last-minute change. Basically, 1 week ago, I had a new idea for a talk. So I wrote a brand new talk, and I'm now delivering it today. I want to talk about the humble browser cache, HTTP cache. We've all heard of HTTP cache. We've probably all used browser cache at some point. But I do think because it is so ubiquitous, so widely available, we kind of take it for granted. And I see in a lot of my work, a lot of developers don't necessarily know how to configure their cache control directives correctly. So just an honest show of hands, completely honestly, who thinks they already understand caching headers and cache control quite well? That's very confident. So there's a few people in the room, okay? Again, complete honesty, who thinks caching's a bit unusual, like some contradictory rules in there, you don't know exactly what you need, what you don't need? Who thinks caching's a bit of a mess? I'll admit that that was certainly me until sort of this year. And for those of you in the room who are thinking, oh my god, a 30-minute talk all about caching, that sounds really boring, you're absolutely right, so enjoy. No, so the talk was going to be about largest contentful paint. If you still want to see that talk, you can do. The slides are right there. If you want to see the largest contentful paint optimization talk, please feel free to grab a copy of the slides. The slides for this talk live here. So if you want to continue looking alongside me or sort of follow along in the audience, there are going to be a lot of code snippets and examples in this talk. So if you want to get a copy of them in front of you while we work, that's where you want to look. So my name's Harry. I'm a consultant web performance engineer from the UK, and what that means is I help companies like these find and fix site speed issues. Now, this isn't a very modest slide. This is a very immodest slide, in fact. This is a load of household names, which kind of seems a bit boastful. But the good thing about this talk today is it doesn't matter how big or small your company is. Everyone with a website can make use of browser cache, and they should do. So my aim with this talk is to make sure everyone who works on or even owns a website has their caching directives set up perfectly. There's a saying in my industry which is the best request is the one that is never made, and that's completely true. You can completely zero out any network cost if you get your caching headers set up correctly. But that's the tricky bit. You need to get them set up correctly. So this talk, we're going to look at common mistakes, some key concepts, and some quick sort of almost like cheat sheets and recipes for setting up your caching headers perfectly. So before we get into the good stuff, I want to go through some key concepts. These are going to be some really important things that we all need to understand the exact same as each other. If you understand everything in this section already, please don't feel patronized. It's just very important that we have a shared language and a shared understanding of certain concepts when it comes to caching. The first concept, obviously, is caching itself, and its sister, revalidation. These two topics go hand in hand. So caching is simply how long can I reuse this file without checking for updates. The key bit on this slide is without checking for updates. We don't want a file to be revalidated while it is cached. So this is a really key bit of information that a lot of people miss out on. Revalidation is how do I check if a file has updated after my cache time limit is up. And again, this is a really critical bit. Only after my cache time limit is up. One of the biggest mistakes I see developers make when it comes to caching is that they somehow expect that if they've told a browser to cache a file for a week and they change it after 1 hour, that the browser would get those updates. If you've told a browser to cache a file for a week and you change that file after just 1 hour, the user is going to see the old file for the next 6 days and 23 hours because you've told it to do that. If you think about it, caching is a way of stopping a client speaking to a server. Therefore, we wouldn't expect to see any revalidation while a file is cached. If we see revalidation of cached files, we've got a bug. And we've probably got some conflicting headers. A header that says do this, but a header that says something completely else, which I guess you would call that a cache-22 situation. That wasn't even meant to be in the slides. I just made that one up. That's why it was so bad. So yeah, revalidation shouldn't happen while a file is cached, but developers expect that it would. So the first thing I want you to take away from this talk is that if you've cached a file for a week, you have to accept that a user may see that out-of-date file for up to a week. So the next concepts are fresh and stale. When we talk about cached responses, we talk about a stale response or a fresh response. Fresh is this file is in cache and within its expiry date. This doesn't mean it's the most up-to-date version of the file, because it's in cache. You might have a cached file that is still allowed to be used for 5 days, but you may have changed that file on the server. Even if you've changed the file on the server, the file in cache is still considered fresh if it hasn't hit its expiry date. Stale is a file that is in cache but has passed its expiry date and therefore does need revalidation. And remember, there is that third state, which is there's a file on the server that has changed, but it isn't in the browser cache yet. So it's important to remember that fresh doesn't mean it's the most up-to-date version of the file. All it means is it's in someone's browser cache and they're allowed to keep reusing it. The next concept we should be very familiar with as web developers, request and response. It is most simple. We've got a client, in this case it's a desktop computer, making a request to a server that responds, in this case, with a file. Now, normally, during this talk, I would be saying the word file, but if we're going to be completely accurate, we should be saying response, because it isn't always a file that comes back. You could get a 404 response, which is literally, there isn't a file. So technically, what I'm going to try and do now is stop saying the word file and start saying the word response. Which brings me on to 200 and 304 responses. These are the two kind of responses you should expect to see when you're debugging your caching. At 200 responses, yep, I fetched a full response. That could come from a server, but also if a file does come from browser cache, you also get a 200 response, which is quite confusing. I would actually like to see a new status code, 20 something, that says this actually came from cache. I would like to see a separation in my response code so that I can tell if a file came from cache or not. The flip side is a 304, which is basically a response that says, yep, I checked, and you can reuse the cached old response. Think of a 304 response as like a renewal. You can continue to use the existing file. It means we don't actually need to download anything. The problem with the 304 response is we still went all the way to the server to find out. So we want to avoid these wherever possible. OK, when I first started trying to truly understand caching, the first thing I wanted to know is, what can I ignore? The easiest way to solve a problem is to remove it. So I'm going to do the same in this talk. What headers don't we need? What can we get rid of? What can we ignore? The first thing I want you to do is delete any pragma headers that you find on any of your responses. Pragma is a mistake, and it should have never happened. It looks a bit like this, pragma no cache. This is a caching header, kind of. And it was a mistake. It was never, ever meant to happen. Pragma was a request header, not a response header. But for backward compatibility with HTTP 1.0, bearing in mind we're on H3 now, it was added to kind of give this backward compatibility. It should not be used. Pragma is not specified for responses and therefore should not be used to replace cache control. If you have Pragma on any of your responses, get it deleted. It's a mistake and it shouldn't be there. Expires, this is an interesting one because most responses probably carry an expires header. An expires header looks something like this. What this basically tells a cache is, as soon as this date is reached, stop using this file and revalidate it. Expires isn't bad. It isn't a bug, and there's nothing wrong with it. There's nothing broken. It's just that we have way better options now. So expires is a caching header. It's replaced by cache control. In fact, if you have a cache control header with a max age directive, your expires header gets immediately ignored anyway. What's interesting about this, the problem with expires, is let's say, what date? I think it's the 6th. In 1 week from now, it's the 6th of October, I think. If we create a file and I say expire on the 6th of October, but then I don't change that file until the 1st of December, everything between the 6th of October and the 1st of December has an expires date in the past, which means immediately that file can't be cached at all. That is the problem with setting absolute dates. As soon as a date gets reached and passed, it's a negative date. It's a date in the past, which is effectively saying, you mustn't cache this file. That's the problem with expires. That's the problem with absolute times. So if there is a cache control header with max age, it will immediately replace expires anyway. So if you've got both, you can kind of leave expires in there. It will get ignored. The way to think about it is cache control does everything that expires does and a whole lot more. The next header we can delete, or that we should get rid of, is last modified. And again, this isn't bad. We've just got better alternatives now. Last modified is used almost everywhere, and I want to teach you about exactly how it could go wrong. A last modified also takes an absolute date, and it simply says, this file was last changed at this time, and as soon as that date is changed, that means there's some new content, download the new version. This isn't a caching header, this is a revalidation header, and it's not harmful, it's just that ETag is way, way better. Date of creation is just a proxy for change of content. Think about it this way. If you've got a static site generator that's very naive, and you change just one typo on your homepage, and your static site generator rebuilds the entire site, every single page on that site gets a new last modified date, when all you've actually done is changed one little typo on the homepage. This is a problem probably in the static site generator, but just because a file was written to disk doesn't actually mean it changed, so we get a lot of false positives. So we can delete those 3 headers. Which ones do we need? We need 2 headers. The first one we desperately want is cache control. We should have seen cache control in the wild. Cache control looks like this. This is just purely an example. Cache control, private, max age 300, must revalidate. You don't need to know about anything to do with private, max age, or must revalidate. We will look at that in a second. But each of those 3, private, max age, and must revalidate, these are called directives. So the first thing here is cache control is extensible. If we invent a new directive, we just put a comma and add it in. We can extend cache control. We can't extend expires. So it's a caching header. It replaced expires in 1997, and it is extensible. The other header that we do definitely need, we want ETag. ETag looks a bit like this. We can have weak ETags. A weak ETag is normally a hash about a file's metadata. A good analogy would be, think of a title of a book. You could tell someone, read this book, and give them a title. The thing is, there may be 2 different authors, completely different countries, who both wrote a book with the same title. A weak ETag is like a book's title. It could refer to many books. A strong ETag is like the book's ISBN number. It identifies that specific book and that book only. A strong ETag is usually going to be a hash of the exact contents of the file, and it will be a byte-for-byte likeness. Strong ETags are slightly more expensive in terms of CPU to generate, but if you can get here, that is the gold standard. This is a revalidation header. We can have weak or strong. We would prefer strong, and it's more reliable than last modified. So those are the 2 headers we do want. We want cache control. We want ETag. We're about to go into loads more detail about those next. OK, so we don't have enough time to make this a real quiz, But what I want you to do is I'm going to propose or present a load of questions. I want you to just turn to the person next to you and have a quick discussion and see if you can work out the answer. Then I'll put the answer on the screen. But what we're about to do is solve a load of unique caching problems with a series of simple yes or no questions. The first question I have is, can this response be cached at all? Am I allowed to cache this response? So just discuss for a couple of seconds with the person next to you, what do you think the header should be if we can cache this response? And what do you think the header should be if we can't cache this response? A lot of silence in the room. Okay. If we can cache the response, we simply want something like cache control, max age 3,600. Max age is just a time limit in seconds, so this would be 1 hour. And yeah, that is basically how long can you cache this file. As soon as you put cache control max age, any cache can store a copy of this file. If we don't want to cache a file, it's as simple as no store. No store means that nobody, whether it's a CDN or a browser or a proxy, nobody may store a copy of this response. So the first concept we introduced there was max age. Max age is a time limit in seconds. It's relative, whereas expires is absolute. So if you say expire on the 6th of October, like I said, as soon as we go past that date, the expires header is in the past, and therefore the file is never cacheable. If we say expire in 1 week, that's a rolling window. We can keep updating what a week looks like. It means we don't have to change the header. We can just keep this, whatever a week is in seconds. This is relative to the moment that the file entered the cache, not relative to when it was created. So the moment it goes into the browser cache, the browser says, OK, this file plus 3,600 seconds is how long I can cache it for. Everything in this slide deck, all the numbers I'm using are just examples. Please don't copy and paste anything from these slides, because they're just examples, right? The other thing we looked at is no store. And there's not much to say about this. No store. No cache at all is allowed to keep a copy of this response. That's all you need to know. You may see really aggressive no caching headers like no cache, no store, must revalidate. Nothing harmful about this. It's just that those two won't do anything. No store is all you need. OK, does this response always have to be perfectly up to date? Do we always need the most up-to-date version of this file? This is subtly different to the previous question, but do we have to always have the most up-to-date version of this file? Again, if you want to just discuss it with the person next to you, 5, 4, 3, 2, 1. If the file has to always contain the most up-to-date content, we need cache control, no cache, which is weird, because cache control, no cache doesn't mean don't cache the file. That's what no store does. No cache means you're not allowed to go to the cache first. You have to go to the server first. So if you always need the most up-to-date version of the content, you just need a no cache header. Otherwise, we've got a similar scenario as before. We just put a max age with whatever time limit we dictate. So we just looked at no cache there. No cache gives us this sort of opportunity to always have the most up-to-date content. But if the content hasn't changed, we can then retrieve the file from browser cache. So remember this pattern we had earlier. We get a 200 response where the browser goes straight to cache and returns a file. This is forbidden. This will not work anymore. As soon as you put a no cache directive, the browser has to go to the server first, not the cache. So forbids the browser from going straight to the cache, which means it always goes to the server, which means you always incur 1 round trip of latency, which means that if the file was really, really small, let's say it takes you 200 milliseconds to get from your computer to a server and back again, but the file was so small, it's a tiny little tracking pixel maybe. Maybe the file only took 50 milliseconds to download. No cache isn't actually any faster, because you've basically saved a 50 millisecond download, but it cost you a 200 millisecond round trip. No cache is only helpful. You only get a performance benefit from no cache if the file was quite large. OK, can this response be shared? Can we allow multiple people to make use of this response? OK, if you think you know the answer, turn around, tell your friend, show off about how clever you are. I'm going to have to speed up a little bit. I told you we don't have time to do a proper quiz. Can this response be shared? Is this a file that we could allow multiple people to have a copy of? You probably want every single visitor to your site to see the exact same style.css. But you probably don't want them all to see the same /my account. That would be disastrous. That would be terrible. So if multiple people are allowed to view the same file, we would use cache control public. If we don't want people to see the same copy of the file as everyone else, we would use cache control private. A friend of mine told me about this while I was researching this talk. My friend told me there was an issue with Steam. Years ago on Christmas Day, Steam was getting a lot of hits because everyone's got new consoles, whatever they've got, everyone's wanting to play their games on Christmas Day. So they introduced a new caching layer, and they accidentally put public in the caching headers. So loads of Steam customers were logging in, seeing other people's credit card details. Dangerous, right? You can look at Christmas Day Steam caching issue. They accidentally put public in a cache control header, so all the /my account pages were shared amongst all their different users. Disastrous. Interestingly, you don't actually need public at all. The moment you put a max age header, public is implied. So you don't ever need to put public, and in fact, public has side effects. I don't have time to go into it, but public actually has some fairly dangerous side effects. So leave public out. Only use private if you need the file to be securely linked just to one person. Diagrammatically, that would look like this. If you've put public, or you've missed public out of a header, a file leaves a server, goes through your CDN, stays on the CDN, and we can just recycle it. Notice how the file stays on the CDN. Private, on the other hand, is only the requesting client may store a copy of this file. This means we don't leak data. Diagrammatically, file leaves the server, goes through your CDN, and keeps on going. The file never stays on the CDN. That's what private would do. Can we reuse this response? Oh yeah, this is where, in order to get yes or no answers, I have to write the most ridiculous questions. These questions start to get really oddly specific. Can we reuse this response for offline visitors, right? Even if it's gone out of date? This is a super edge case, but here's something really interesting. Browsers, if they go offline, can and will reuse a file even if it's gone stale. So if we can reuse this response for offline users, cache control, max age, whatever, same header we've seen a bunch of times before. If we don't want to allow this, we put must revalidate. What must revalidate says is the moment your time limit is up, you have to come back to the server, and if the user is offline, just show them a 404 page. If you've ever been on an airplane, or you're on airplane mode or something, you're not connected to either data or Wi-Fi, your phone is completely isolated, and you open your browser, and there's a page still there, and it's like, oh, that's interesting. That's because they didn't put must revalidate on that header. The files come from cache, and they can still show you it when you're offline. So must revalidate. Caches are allowed to serve stale content in certain scenarios. For example, if someone's offline. Must revalidate stops this from happening. Must revalidate, you would not use it on anything that needs to be super up to date. So a live train timetable of like live train times, you would want to put must revalidate on that. But anything static, like a recipe, if you've got a food blog, or an article on a news page, yeah, the news doesn't change that quickly. So must revalidate, you could probably leave it off. HTTP allows caches to reuse stale responses when they're disconnected from the origin server. Must revalidate prevents that. The questions get even weirder. Can we tolerate a slightly out-of-date response while we perform revalidation? I told you this is getting really contrived. Revalidation is synchronous. Let's say somebody visits your site and style.css has gone out of date. That means the browser can't render the page until it goes all the way back to the server, checks if it needs a new style sheet, and then comes all the way back. That is synchronous, so the user sees nothing at all while it happens. What you can do is say, yeah, OK, for 5 more minutes, show them the old style.css while I get the new one in the background. This is called stale while revalidate. And what we're saying here is, OK, reuse this file for 10 more minutes, but in the background, make sure you're updating it. If we don't want to allow this, if a file has to always be perfectly up to date, then we would use cache control max age. Stale while revalidate is quite new, and it's really, really powerful, and it makes revalidation asynchronous. For example, a decorative image in a blog post. Let's say you update an image to be something different. It doesn't matter that the decorative image is 10 minutes out of date. We can recycle it while we revalidate. What this looks like is immediately we get a 200 response from cache, even if the file is stale. In the background, we do a conditional request to the server, And it comes back either with a 200 with a new file, or with a 304 that says, no, you're good, keep using the old one. Stale while revalidate is very, very powerful, and it's usually a really good candidate for images. I've been working with Cloud Enemy recently, the image transformation service, to add stale while revalidate to their image responses. It's going to save a lot of bandwidth and also really improve the user experience. Do we need to configure CDNs and browsers differently? Do we need to tell our CDN to cache files differently to how the browser is going to do it? If yes, we would use the S max age header. You may have spotted this. There's something really annoying on this slide. On the top, there's a hyphen between max and age. On the bottom, it's just max age, all one word. That kind of inconsistency really bugs me. What this says is the browser can cache a file for an hour, but the CDN can cache it for a day. If we don't want to do this, if we don't want to configure them differently, we would just use max age as normal. So S max age. S stands for shared cache max age. A shared cache, usually we just mean a CDN. First question is, why would you want to configure shared and private caches differently anyway? Why would you want your CDN to cache a file differently to your users? There's a really elegant explanation. That is that cache busting is a myth. We talk about cache busting. It doesn't really exist. You can't cache bust your user's device. That's why people on customer support get so annoyed explaining to people how they bust their own cache. Go to settings, go to files and data, clear cache. You can't clear your customer's cache. Right? Cache busting is a myth. But you can clear your CDN cache. So what you could do is say, OK, every user keeps a copy of this file for an hour. The CDN keeps it for a day, or until we do a release. You can flush your CDN cache whenever you want. It's a good way of shielding origin. So your users go to the CDN every hour, but the CDN only goes back to origin every day, or on demand. This shields... sound just dropped out then. This shields origin, but also means you can get fresh content to your users, and it's a really elegant way of handling that sort of setup. OK, is the file hashed? For example, do we have a fingerprint in there? Show of hands, whose build puts fingerprints in their file names? Whose build does this? Only like 10 of you. Wow, OK. If you can get your build configured to put fingerprints in the file names, amazing. As soon as you do that, we can do this. Max age, that's 68 years. Immutable. Immutable is really, really powerful. Immutable makes a contract with the browser. If we don't have fingerprints in our files, we just use max age like normal. So immutable, what does this do? If you've got a fingerprint in your file name, if you've got a hash in your file name, that file never changes. Because as soon as you change the file, it gets a completely new name. And if a file gets a completely new name, it's a completely new file. The key here is that fingerprinted files' content never changes. So they never need to be revalidated. What you do is you make a promise to the browser, hey, this file is never going to change. So don't ever come back to the server. And then if you've got that, you put immutable, and then you can cache the file forever. In computing terms, how long is forever? It's whatever that number is. That's the biggest positive integer you can store in 32 bits. 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. The spec says that all caches must honor this number, which is 68 years. If you remember the Millennium bug, we've now got the 2038 bug. This is the 2038 bug. So yeah, forever is 68 years. OK, I really need to hurry up now. I'm running out of time. But basically, the next section is all about revalidation. Now we know exactly how to cache a file, how to store it, how to safely store files. How do we communicate to the browser that a file has changed? We need to revalidate it somehow. Technically, we don't actually need revalidation. What you could say is, OK, cache this file for a week, then after a week, download a new copy of the file, regardless of whether it's changed or not. We don't actually need to know if a file has changed. We could say, cache it for a week. After that week, grab a new copy, whether it has changed or not. But that's wasteful, right? We could say just always fetch a new copy, even if we don't need to, but that is wasteful. And as performance engineers, we don't like waste. So what we do is we ask a question. Can I renew this file? And then the server will respond yes or no. So we talked about last modified versus etag really quickly. These are revalidation headers. We prefer etag. What a browser will do when a file has gone stale is it will emit a conditional request to the server that says, hey, look, Has this file changed since this date, or has this hash changed from the one I've got stored? So what this looks like is we get a conditional request to the server. If we get a 200 response, we download a new copy of the file. If we get a 304 response, we're allowed to recycle the old file and cache it for 1 more week again. So these are called conditional requests. If you're using e-tags, the browser itself knows how to do this. You don't need to configure this. If you've got e-tags, the browser will put, if you don't match this hash, give me a new file. If you're using last modified, the browser will automatically put this on your request headers. You don't need to configure this at all. If it comes back true and the file has changed, we get a 200 response. If a file hasn't changed, we get a 304 response, and we're permitted to recycle and reuse that file. We prefer e-tag. I've already talked about this, so I'll go through this section quite quickly. E-tag is better than last modified. Last modified changes whenever a file is written to disk, regardless of if its content changes or not. E-tag only changes if the file actually has an update. For example, this isn't a caching mechanism I'm about to show you, but I've got a little demo here. I'm writing the phrase hello world into a file called revalidation. I then get the last modified date of that file, and we'll see that it was 18:37 and 50 seconds. I get a checksum of that file, and it's 6F5902. Then, about a minute and a half later, I write the exact same content into the exact same file. The last modified has changed to 39:23 seconds. The last modified has changed. Get a checksum of the file. That hasn't changed. If you've got a build step that touches your entire file system, all your last modified dates will change, even if the files haven't. This is why we prefer e-tag. E-tag only updates if the file has changed. Coming back onto the topic of hashed responses, we don't need to revalidate them. As soon as we've put a fingerprint in our file name, we don't need to revalidate anything. Because hashed files never change, there is no need to revalidate them. So, with 5 seconds left, 3 more minutes. Oh, well. You like that? OK, so just to kind of wrap up. What have we learned? Hopefully, we've learned quite a lot. This is a very dense talk. There's a lot in here. We shouldn't expect to be able to fetch new content while a file is cached. If you've told a browser to cache a file for a week, you have to accept that a user might see out-of-date content for almost a week. This is why it's super important that you pick the values of your max age very, very carefully. If you've got a file that you know you change every release and you release 10 times a day, don't cache it for a year. We only have 2 jobs. We only need 2 headers. The biggest problem I see with developers and caching is they overcomplicate it. They overthink things. We only need to do 2 things, cache a file or revalidate a file. Therefore, we only need 2 headers. We need cache control and we need e-tag. The other thing we learned is that expires and last modified aren't bad headers. They're not bugs. They're not problematic. It's just that cache control and e-tag are a lot better. They give us more extensible support for new features, and also they're more accurate. And again, I've said this too many times now, files that never change never need to be revalidated. If you've got a fingerprint in that file, put immutable on there and cache it for 68 years. So, last thing I want to leave you with is some little cheat sheets. We've talked a lot about different things, and sort of one thing I said was be very careful with the values that you choose for your max age headers. I put this little graph together, and what we should think about is files that we want to cache never, files we want to cache for a short time, a medium amount of time, a long time, and forever. Forever is however many weeks is in 68 years, and never is obviously 0 seconds. So examples would be my account, sensitive information that needs to be up to date, API responses that need to be up to date, put them in the never category, put no store on them. /news. News, you want it to be fairly up to date. So maybe you cache a news homepage for 5 minutes. Everyone can live with news that's 5 minutes old, right? Store locator. Unless your business is doing so well that you open a new store every day, you could probably cache your store locator page for a few hours. Maybe a product image. Product images don't change very often. Maybe you cache a product image for a matter of days. And then something like a fingerprinted app.css, we can cache that for forever. The next little cheat sheet is if your assets are non-versioned, if your assets don't have a hash, don't have a fingerprint, you will need cache control, but you will also need etag, and you will need more granular cache control directives. If your file has a fingerprint, you can cache it forever, which is 68 years, and we can put immutable on there. 5, 4, 3, 2, 1. Thank you very much. All right, do we have time for questions?
Thank you. The questions in the speaker's corner?
Speaker's corner, cool. And if anyone wants to talk about the largest contentful paint talk that I didn't do, you can ask me about that as well. Cool. Thanks, everyone.
So please, big applause for Harry Robert!
Challenge accepted. Challenge
Cheers, guys.
accepted.